All right, you guys can see me. You guys can see this. We're good to go, right?
Yes,
Yes?
sir.
Okay, good. All right, so basically we're going over number 13. We're talking about theoretical yield and actual yield. Theoretical yield is how much you're supposed to get based off of the chemical reaction, right? So you can work that out, right? Using stoichiometry, you know how much of a certain chemical you're supposed to get at the end of the reaction, right? What product you're supposed to produce or how much of a reactant you were supposed to have to get the product that you got, okay? But the actual yield is going to be how much you actually got, right? So what happens? Sometimes we can't control everything that's happening in the lab. So we'll get a little bit more or we'll get a little bit less of the product that we're supposed to get, okay? Maybe we made a mistake ourselves, or maybe other reactions are happening inside of our space that we're not aware of, okay? Or maybe the reaction is a reaction that can go both ways. So maybe it starts going backwards also and trying to reach equilibrium. Okay. So that's basically the difference between theoretical yield and actual yield. And what this question is asking, what is your percent yield? And your percent yield is basically just going to be comparing your actual yield to your theoretical yield. And the equation is really, really simple. Okay. The equation for percent yield is going to be actual over theoretical times 100%. Okay, and that's going to be your percent yield. So let's go ahead and do this. If a chemical reaction produces 4.19 grams of NaOH, right? So that's our actual. That's our actual, right? What would be the percent yield if the reaction theoretically is supposed to produce 6.00 grams of NaOH. So let's pretend we had a reaction that went like this. We had something right here, and we know that one of the products is NaOH, okay? We know that one of the products is NaOH. So we go ahead and we work this out, and give me 1 second. Okay, so we go ahead and we work this out, and we realize that the theoretical yield we're supposed to get 6 grams of NaOH at the end of the reaction, right? But we only got 4.19, so we're just going to plug it in. Okay, it's actually a pretty simple problem. Okay, so percent yield is going to be the actual, which is 4.19 grams of NaOH, over the theoretical, which is 6.00 grams of NaOH, times 100%. Now, be careful with this 100%. I'll tell you about that now in a second. And then once you do that in your calculator, okay, we're going to do 4.19 divided by 6.00. All right, and then we're going to multiply that times 100. Do not multiply it times 100%. If your calculator has an option of percentage, do not plug in to calculator. Okay, do not plug in the percentage sign into your calculator, because basically what that'll do is that it'll take that 100, right? And it'll make it 1 over 100, right? It'll divide it, sorry, it'll make it 1. It'll divide it by 100, okay? Because remember, percent means per 100, per means division, so it's going to be 100 divided by 100 is going to be 1, okay? So don't plug in this percent sign. That just means that all of this grams of NaOH are going to cancel out, and your new answer is going to be a percentage. Okay, that's just the unit that your new answer is going to be. Okay, so we're going to multiply that times 100, and then you're going to get 69.83%. In this case, we have 3 significant figures, so your final answer is actually 69.8%. Okay? And that's just how much of the product you got versus how much you were supposed to get. So you got 69.8% of it, about 70%. Most of the time, that's actually like not a good yield, right? You want to, depending on the reaction, right? But you want to like be in the 90s. Okay. Any questions on that one? Number 13. You guys understand it? Yes? No? You guys want to do another example of it? Are you guys still there? I need some
Yes.
feedback. Yeah. Okay.
Yes.
We're good.
Okay. All right. So I can move on to another one. Let's do another
Yes.
one then. Anyone else have another one that they want to go through? So that was number 13. Does anyone else have another one? If not, then I'll go over one that I've chosen.
Sir, could we do 23? I think it's H.
From the chapter review?
Yeah.
Yeah, of course. Okay, so let's go in the chapter review 23. So you mean this one? What is the theoretical yield of NaCl in grams? This one? Yes? No?
Yes.
Yes? Okay. So this one I actually did in the last Zoom call. Okay. So instead of redoing it right now, let's go ahead and just watch that video from the most recent Zoom call. I uploaded all of them on YouTube. I put them on our page. We did this one together. I think Matthew was there, Brian was there, Pineda was there. I don't know who else was there. Do you guys remember doing this one? Yes. I'm pretty sure
Yes.
that this one. Yeah. Okay. So we did this one on the Zoom call. Go ahead and just watch that video for that one, okay? I'm gonna do one similar one though from the worksheet, okay? So
Yes, sir.
so that one
Yes,
was
sir.
what is the theoretical yield of NaCl in grams? Okay, so basically a very similar one, stoichiometry.
Sir, my Zoom is acting weird. I'm just gonna leave and rejoin.
Okay, is that Brian?
Yeah, it's me, Brian.
Okay, no problem. Okay, so let's do this one. Basically, when something is asking what is the theoretical yield of something, that's just asking how much of the product is supposed to be produced, okay? So you don't have to like get too worried about the wording, okay? We're gonna do number 8 from the worksheet, okay, which asks, for the reaction below, how many grams of sodium sulfate will be produced if 39, give me 1 second. So Brian's back. Everyone's good.
Yes, sir.
Okay, let me take one more quick shot of everyone that's on here. Okay, good. So basically, all it's asking is how much of the product is produced. So the word theoretical yield, don't get too worried about that word. That just means how much of the product is produced. So let's go and let's, first of all, always write the equation. So we're doing number 8. We're going to write that equation down. First thing we're going to do, 2NaCl plus H2SO4 produces Na2SO4 plus 2HCl. Okay, so that's our equation. And now we're going to just go ahead and figure out what we're starting with and what we're finishing with. And if you guys have been watching the videos or joining the Zoom calls, you know that this is basically what we do every single time. So the question is asking, now, start and finish, that doesn't mean reactants and products, okay? Now, this is based on the question, okay? This is us doing work now, all right? So what are we starting with in the question? Let's see, who's on here? Let's see, Josen, can you tell me, according to the question, what are we starting with? So what are they giving us? What information are they giving us? Josen, going once.
Sir, I'm gonna be honest with you. I don't really know.
Okay, and that's okay. All right, and I'll make it like real simple for you guys. Most of the time, the questions that we're dealing with, whatever numbers you see is what you're starting with. Okay, so in this case, unless they give you different sets of numbers, all right. In this case, they're giving you in number 8, 39.2 grams of sodium chloride. Okay, so 39.2 grams of sodium chloride. That's what you're starting with. Okay, most of the time it's going to be that way. So remember that. Okay, that's just a trick to get to where you need to go more quickly. All right. How many grams of soda? So what are we finishing with? we're given the grams of sodium chloride, and we want to know the grams of sodium sulfate. Okay, do we know the grams of sodium sulfate? Have they given that to us? No. Okay, so
No.
that's what we want to find. All right, so according to what we've done before, we have this kind of this template of what we need to do when we're dealing with stoichiometry problems. We're going from grams of one molecule, right, to grams of another molecule. Okay, but we can't jump from grams of one molecule to grams of another molecule. What unit do we have to be in to make that jump from one molecule to another? What's the only unit that we can jump
Moles.
in? Moles, exactly. Okay, so what we're gonna have to do is convert this grams into moles of the first molecule, and then convert those moles into moles of the second molecule. Okay, and then we can go to grams, and we know how to go from grams to moles because we just use the molar mass. All right, now it's almost 10:30, so at 10:30 you guys can log off if you need to, and that's okay. No hard feelings at all. You can just log off, but if you want to stay for the end of this question, this is the last question that I'm going to do. If you guys have any more questions over this, you could just ask me. I can guide you through it, maybe make a video for you or something. Okay, but just understand that the test is going to be on Monday. I'll try to have it done. I'm going to try to like finish it today. It's finished. It's just like on paper, and now I need to transfer it over to Edmodo. So that's it. Okay, just so you guys know. So at 10:30 you can start leaving if you want to. Your attendance has already been noted. But if you want to stay, help me finish this problem, even better. Okay, so let's finish this one. So we're starting with this, and we want to finish with the grams of Na2SO4, but we have to convert to moles first. So the first thing we want to do then is to make our bridge. Okay, we have to make a bridge so that we can cross through it. And now this bridge, since we're going from grams of one to grams of another, this bridge is going to have 3 columns. Okay, and the more you work through it, the easier it'll be to figure out how many columns you're supposed to have in your bridges or not. Why? Because we're starting with grams here, then we need to go to moles here, then we need to go to moles again, then we need to go to grams over here. So we need 4 spaces. Okay, whenever we're going from grams of 1 to grams of 2, we need 4 spaces in our bridge. Okay, now let's fill out what we know. Remember, we always put in first what we start with, which is 39.2 grams of NaCl. Okay, is there anyone confused as to how I knew that this is what I had to put here?
You add them both together. Eh?
I'm sorry?
You add the number of Na with Cl, right?
Yes, for the next step. Yes, you're right. Yeah, to get to moles. Yeah,
Okay,
yeah.
okay.
Okay. But I was just asking how we knew that this was what we needed to put here. Basically, whatever you're starting with is what you're putting here. Whatever you're finishing with, you don't know what the unit is. Sorry, you don't know what the answer is, but at least you know that you're supposed to finish with a unit of grams of Na2SO4. Always do this, guys, okay? It'll help you so much if you just go ahead and set it up this way, the way that I did right here with the bridge notation, okay? Let's go ahead and let's fill in the rest that we know. Now, we know that to be able to go to grams of Na2SO4, we need to go to moles of Na2SO4. But before we do that, we have to go to moles of NaCl. Okay, so we know that we need to go to moles of NaCl over here. All right, now 1 mole of NaCl, here we're going to put the conversion factor, and the conversion factor is going to be found by using what, Brian?
Adding.
Exactly, adding what? What are we adding?
39.2. I don't know, to be honest.
Okay, so you're close. We're trying to find the mass of NaCl of 1 mole of NaCl. So basically the molar mass, right? The molar mass of NaCl is going to be found on the periodic table, right? we add the mass of Na, which is 22.99, plus the mass of Cl, which is 35.45, right? Yeah. Now, what is that? 22.99 and you get 58.44. Okay, so now we know that basically the molar mass of NaCl is 58.44. And why did we need the molar mass? Because we want to convert to moles, right? We want to convert to moles of NaCl. We have grams. We have an amount of NaCl that we're starting with. Now we need to figure out how many moles of NaCl are in that amount that we're starting with. And the only way to do that is by doing the molar mass, okay? And now we see that we have grams up here and we have grams up here, so they're going to be able to cancel out, okay? Now, we went to moles of NaCl. Now we need to make that jump to moles of Na2SO4, okay? And how do we make that jump? What do we use?
Mole to mole ratio.
Mole to mole ratio, exactly. Okay, so here we use the mole to mole ratio. Okay, and how do we find the mole to mole ratio? We just look at our equation. Basically, in this equation, 2 moles of NaCl, okay, 2 moles of NaCl are going to produce theoretically 1 mole of Na2SO4. The only thing you need to look at is the coefficients. Okay, the coefficients tell us. All right, so basically we're just going to use this, the mole to mole ratio. This is how we make that jump from reactant to product, okay, or from one molecule to another molecule. Now the last step is to try to get grams of Na2SO4, and the way that we do that is by using the molar mass again. So let's find the molar mass of Na2SO4. How do we do that? Go to the periodic table again. So we have the molar mass of Na2SO4 is going to be, so Na2, that's going to be 22.99, right? And that's times 2 because there's 2 of them. Okay, so Na2 is going to be 45.98 plus, we have S, which is sulfur, which is 32.06, all right, plus O4, which is 16 times 4 because there's 4 of them, okay? And then we add that all together and we get 142.04. Okay, and that's the molar mass in grams of 1 mole of Na2SO4. Okay, guys? So you have everything you need. Now, before you start working it out, what you should do is check that everything cancels out. Okay, so we're going to check that everything cancels out. We have grams of NaCl, grams of NaCl cancels out. Canceled out what we started with. Mole of NaCl, mole of NaCl. Mole of Na2SO4, mole of Na2SO4, and we're finishing with grams of Na2SO4, which is what we want. Now we're going to be that little person, and we're just going to walk across the bridge, okay, on our calculator. All right, so let's go ahead and let's write it all down. We have 39.2, right? Whatever's at the top gets multiplied. If it's a 1, we don't need to do it. Whatever's at the bottom gets divided. Divided by 58.44, divided by 2, times 142.04. We do that, and then we finish with 47.638. 38. Let's do one more, 3 grams of Na2SO4, but we're not done because the last thing that we need to do is find the significant digits. Here we have 3 significant digits, so our answer can only have 3 significant digits, which means that we're looking at this 3 here, And this 3 tells us if we're going to let it soar or let it rest. 4 or less, we let it rest. Okay? Which means that our final answer is going to be 47.6 grams of Na2SO4. And that's it. Okay, so basically what we're saying is if you start with 39.2 grams of NaCl and you run it through this reaction, you should get 47.6 grams of Na2SO4. Okay, so take a good look at this right here. All right, I'm going to stop the sharing. All right, and then we're done.